class, welcome back. Today we will be discussing difference between fission and fusion, description of nuclear energy. First, we will start with the definition of nuclear energy. The definition of nuclear energy is defined by the energy released by a nuclear reaction. Next, I created a table discussing the difference between fusion and fission. First, we'll start with fusion. Fusion is the fusing of two or more lighter atoms into a larger one. It generates the power of the universe, often occurs in the sun. A high density and high temperature environment is required. The energy released by fusion is 3 to 4 times greater than the energy released by fission. There's an extremely high energy required to bring the two or more protons close together that overcome nuclear repulsion. Alright, an example of that would be this example with the isotopes of hydrogen, hydrogen-2 deuterium, and hydrogen-3 tritium. It basically shows the fusing of these lighter protons into a larger one, into a larger hydrogen molecule. Fission is defined by the splitting of a large atom into a smaller one. That's shown as this picture. Neutron, which is this big little blob, minus induced, which is the energy required, and fission breaks the two bigger neutrons into the two smaller ones. It doesn't often occur in nature. The critical mass of the substance and high speed of neutrons is required. The energy release is 1,000,000 times greater in a chemical reaction than it is in fusion. It generates electricity for power plants. It also occurs when uranium is bombarded by neutrons, and it produces many highly radioactive particles. So, in conclusion to today's activity, we discussed the definition of nuclear energy, as well as discussing the difference between fission and fusion in a table format, as well as showing pictures of how these two nuclear energies break apart. See you guys next week.